Okay, so last topic let's talk about here. I think we can get this on the last video. The idea of a manometer. Manometer, manometer. Manometer, again, as you're writing your notes, I'll write notes with you. A device used to measure pressure with the height of a fluid column. Now, how does that help us? Well, remember, we've got this fundamental expression back here on what is actually page 6. Right? We've got this fundamental expression back here we derived based on Newton's second law that says the pressure change within a column of fluid is directly proportional to the elevation change within that column of fluid, or inversely proportional to the elevation change within that column of fluid. Based on the weight, this is essentially the weight of the fluid above. So as you increase the amount of fluid above you, you increase the weight of the fluid above you, and therefore you increase pressure. What we can do is we can use this same exact phenomenon to measure pressure change. So we know that if I move from one point in the fluid to another, I will experience a pressure change. If I move down, I'll experience a pressure increase. So if I have a column of fluid between two locations, I know if there's an elevation difference between the two surfaces of that fluid, I know that there's a pressure difference causing that column of fluid. When you use a straw, you're using this principle. Okay? So what we can do is let's say that I've got some sort of a compressed gas trapped within a tank, and underneath that gas I've got liquid. So we could just use air and water here, and that would be okay. Right? And let's say that this portion of the tube is open to the atmosphere. Right? So if I want to know the pressure of the gas inside, well, I could attach a tube containing liquid, and as long as the pressure is not so high that it just squirts the liquid out the other end, right, then I could just set this up, and I can actually say, well, you know what? I know that the difference in pressures based from one point in the column of fluid to the other is just based on the density of the fluid times gravity times the elevation difference between those two locations. And we say, well, let's say this is 2, right? This is 2, and we'll say this is 1. You could call either one, right? That's arbitrary. You don't have to call this 1. I like calling 1 the atmosphere, if possible, but you don't have to. Okay? So we call 1 the atmosphere, and notice then I'm saying, well, Z2, I can set, what I would suggest is set one of these to be 0. It doesn't have to be the lowest elevation. It just has to be a point that you can measure everything relative to. Well, if I can measure this elevation difference, we'll just say a generic H is often what we use. If I say that this one is 0, that means this is a positive H. And as we said earlier, I could call this 0 and this is a negative H. And mathematically, I'm going to get the same thing. It doesn't matter. I just have to pick one of them to be 0, or some location to be 0, and the other one has to be H. I could say that this one is 365, and this one would be 365 plus H. That's fine, too. Mathematically, I get the same thing. I like to call one of them 0. A lot of times, if I can call the bottom 0 and everything above it's just a positive, that's fine. But it just needs to be some value you can measure everything relative to. So again, if I say P1 is equal to the atmosphere, we say this is a 0 height and this is height H. And this becomes pretty simple. P2, which is the pressure of the gas that we're after. P2 is the pressure of the gas that we're after, and that's equal to P1 plus rho G Z1 minus Z2. And we find that P2 is just equal to the local atmospheric pressure plus rho GH. And notice this is a gauge. This is basically a gauge that's measuring pressure. And you can say, well, the gauge pressure, which of course is P2 minus the atmosphere. Well, if I take P2 minus the atmosphere, this just ends up being rho GH. So the gauge pressure at point 2 would be rho GH. So the question becomes, do I need the absolute pressure? Well, that's where the atmosphere is added in. Or do I need the gauge pressure? And the gauge pressure is just the difference between the pressure here and the pressure there. In this case, because this point is the atmosphere. Now, if this is not the atmosphere, then the gauge pressure is not necessarily rho GH. Okay? But since this one's open to the atmosphere, the gauge pressure at this point is rho GH. Now, if this was open to, say, a vacuum, right? Or if this is a straw, if I've got a straw in here and I'm pulling liquid out with a straw, well, the pressure in here is going to be less than the atmosphere because what I'm doing with my mouth is I'm decreasing the pressure in my mouth to basically pull. What I'm doing is I'm using the pressure in here to push the liquid into the straw and into my mouth by lowering the pressure in here. So if you're using a straw, the pressure inside your mouth is not atmospheric pressure. It's actually less than. Okay, so this gauge pressure, this only works. I can only say that the pressure here is equal to rho GH because this one's atmospheric pressure. Okay. All right. If you have questions, send me an email, leave me a comment, find me in the chat room. If the normal chat room time doesn't work for you, send me an email and say, hey, can I meet you at this time in the chat room? And we'll find something that works. All right, guys, I am going to try to not lose my voice. I'm pushing it here. I know I need a break. I'm sure you guys need a break. Again, there's a homework assignment out there for Chapter 1. This should get you really far into that homework 1. Okay, so look through it, work through that, get that done, turn it in on time, scan it as a PDF, load it to Canvas. Ask me if you have questions. Right? If you don't ask me, I have to assume that you don't have questions. That's the disadvantage of the online class. I try to make myself as available as I can. If you have suggestions on what I can do to improve that, please let me know. I'm learning online classes as I go. And I'm not going to lie to you and say that I love online classes. I don't. But anyway, it is what we have. And we'll be okay. We will get through this. We made it okay in the spring. We'll be okay this summer. All right, guys. Seriously, let me know what I can do to help you. Otherwise, stay safe out there. Wash your hands. Social distance. Wear a mask. Let's not let this thing go any longer than it has to. All right, guys. Have a good one. Bye-bye.